Okay, so it is day 16 today. We are now past the halfway point of term 3. It's pretty crazy. And your due now today was just to do this worksheet, finish as many problems as you could. So I am thinking what I would like to do is have us go through each one of these 6 problems here, and before we graph the lines, let's just fill in all the information that I kind of gave you to the side of each graph and make sure that we understand how to get that piece first. And this is a bit of review. We've been working on this for the last few days now, but let's just make sure we got it. So on number 1, what is our y-intercept? -3, good. -3. What's our slope?
2 over 1.
Perfect, 2 over 1. Okay, and is this a solid line or a dotted line?
Dotted.
Dotted, good. Now how'd you know it was going to be a dotted line?
Because of the sign after.
Yeah, the sign. We have a greater than sign. If it was greater than or equal to, then it would be solid. But since it's not equal to, it's dotted. Good. And then would we be shading up or down? Up. Good. Perfect. Perfect, perfect. Okay, let's fill in our information for number 2 now. What's the y-intercept on number 2? 2. Good. How about our slope? Perfect. -3 over 4. And are we solid line or dotted line? Solid. We've got less than or equal to, so it is solid. And then are we shading up or down? Down. Good. Perfect. Perfect, perfect. Okay, now let's look at number 3 real quick. This one's a little tricky. All I have is y is greater than or equal to 3. So what do we do whenever we have an equation that just has y, then a symbol, and then a number? There's no x, just y.
+0.
Say it one more time.
+0.
+0. Could be +0.
You substitute any number.
Substitute my number. What do you mean?
So like x. So like put in a number. Really.
Okay, so do you mean in my coordinates that I gave you, or yes? Okay, so what is this telling me? I have y and then a 3. What does that tell me about my coordinates?
Y is going to equal 3.
Yes, it means that in my coordinates, my y value is always going to be 3, no matter what. It can have any x that I choose in the world, but my y value will be 3. So let's go ahead and fill in 3 for y, and give me some random numbers for x.
-2.
I heard 4. Give me another one.
-2.
-2. Awesome. So, little note to make. When we have y equals something, or y is greater than something, y is less than something, y is going to be whatever number they give you. X can be any number. That might be a good note to make on your page. And since we have y is greater than or equal to 3, y is always 3 in this case. Okay, now Kiana, whenever you said +0, were you referring to the y-intercept or the value of what x could be?
Honestly, I don't know.
That's okay. I bet what you were thinking of is when we have an equation where it would be like y equals 3x, and then there's no plus something. And in that case, we would say, yes, it's plus 0. But in this problem, we don't have y equals something x plus something. So believe it or not, this is actually our plus 3 at the end of the equation. What we don't have is a slope. We don't have a number next to x. And these are tricky to recognize whenever you're missing variables, just because I find that tricky. You know, whenever something is missing, it's hard to tell that it's missing. I like to just remember that if I say y is greater than or equal to 3, this means that y can be 3. So here's 3 on the y-axis, and it can be anything bigger than 3. So you're going to end up having a line that goes right across here, and then we would shade above. Well, good. That's okay. Okay, so is this a solid line or a dotted line? Solid. Good. We have greater than or equal to. That makes it solid. And then shade up or down? Up. Okay. Perfect. Perfect. Now, I know I said we'd fill out all of the information before we do the graphs, but the more I think about it, the more it makes it feel like we're leaving these all unfinished. I think I want to see the graphs. Do you guys agree with that? Okay, let's go back and do the graphs for numbers 1 through 3 then. So let's look at number 1 again. We have all of the information we need. We've got a y-intercept, a slope, we know that it's a dotted line, and we know that we shade up. So where should I start? -3 on the x or the y-axis? The y-axis, good. So I'm going down to -3 on the y-axis. There's my first point. And where do we go from there? Good, up to over 1. And we just used the slope to do that. Rise over run. So here's our second point. And what do I do next? Yes, we are going to connect the dots, and we decided it is a dotted line. So I'm going to use a ruler, and I'm going to make sure that when I connect my dots, I use a dotted line. Now, I'm going to show you guys a quick trick, just because I know that there's going to come a point where one of us makes a mistake. I'm going to show you kind of how to correct it. Let's say we get in the zone and we draw it as a solid line, and it's supposed to be dotted. Something that I like to do just to show that it is actually dotted without having to totally start all over is you can just kind of put little dashes above the line like this, and I'll be able to tell that's supposed to be dotted. So just a little FYI, if I see this, I'll know that it was supposed to be dotted. Okay, and then where am I shading again? Up. Good. So I'm going to be shading above my line. There we go. Looks pretty good. Okay, any questions about number 1? Okay, let's look at number 2 then. So we already identified all of our important information for number 2, so graphing shouldn't be too difficult. Where do I start for my graph? 2, positive 2 on the y-axis, good. And where should I go from there? I'm going to use my slope, so my rise is -3. I'll go down 1, 2, 3. Over 4, that's my run. 1, 2, 3, 4. There's my second point. And do I have a solid line or a dotted line? solid. Good. And on this one, we shade down. So I'm going to connect my dots. And we're going to shade below the line. There we go. That is what our graph should look like. Something like that. Okay. All right, now let's look at number 3. Does anybody still need number 2 though? Can I move it or do we need a moment? Okay, I'm gonna go ahead and move it. So, number 3, we have y is greater than or equal to 3. So we decided that whenever we have an equation, or in this case an inequality, where we're told that y is always either greater than or equal to 3, that means if we were to think of this as graphing coordinates, our y value will always be 3 because they gave that to us. So y is always 3, and then x can be any number we want. So let's go ahead and plot these points that we came up with. We just decided on 4, 3, and negative 2, 3. You could have chosen any values for x that you want though. So for my first point, I'm going to go over 1, 2, 3, 4, up 3, 1, 2, 3, here it is. And then my second point, I've got negative 2, 3, so I'm going to go over negative 2 and up 3, right there. You can also remember that when we have y equals a number, it's always going to be a line going straight across left to right at whatever number they tell you. And we decided this is a solid line, so we're just going to connect the dots and make it a solid line. And because it's greater than or equal to, we are shading up. Just like that. Okay, do we have any questions on number 3? Okay, can we move to number 4? Awesome. So let's look at number 4 now. This is similar to 3. But it's different. How is this one different than number 3? Yeah, now we have an x instead of y. All of these equations start with y, except for this one. It starts with x. We've got x is less than negative 2. So what does that mean whenever we are given an x value instead of y? The x is less than negative 2 is what they tell us.
So y becomes any number?
Y can be any number, yes. And what is x always going to be? Negative 2. Yes, so if they ever give you a value for x, like in this case negative 2, that means your x value is always negative 2. So I'm going to write on this one, x is always negative 2. So I'm going to put -2 in both of my coordinates. And then just like you said, Kiana, y can be anything. So let's see, give me some random numbers for y. 5 and -4, good deal. Okay. 5 and -4 for y. And remember, y can be any number in this case. Any number that we can see on the graph. Now, is this going to be a solid or a dotted line? Dotted. Good. It's just less than -2, not less than or equal to. So that's dotted. And this time we have different options for shading. Our x-axis goes from the left to the right, not up and down. So when we're shading, we're not going to be able to shade up or down. It won't be possible. We have to choose to either shade to the left towards the negative numbers or to the right towards the positive numbers. So if x is less than -2, do you think we're going to shade to the left or the right? Left. Left. Good. Less than is to the left. Okay, so let's plot these points. We've got x is -2, y is 5. So I'm going to go over to -2 on the x-axis and up to 5 on the y. I also like to, whenever I see x is less than -2, I like to just go ahead right over to the x-axis and mark that -2. Optional, but I like to do that. You could also do that on the previous problem for your y. When I have y is greater than 3, I could just mark 3 on the y-axis. And then we chose -2, -4. So over -2, down to -4. And then we connect the dots. And remember, we said it was a dotted line. So we're going to make sure it's dotted when we trace. Okay. And we decided we were shading to the left. So I'm going to shade to the left over here. Just like that. Okay. Do we have any questions on number 4?
You're going to do a couple of them again after you get done with
You
five.
got it. We can do that
3
today.
and 4.
Okay, let me highlight those. And I appreciate you speaking up, Jenny, because I bet you everybody else is thinking the same thing. We'll do some more of those today. Okay. Can we move on to number 5? Okay, let's look at number 5. Now I have y is less than or equal to 6x minus 5. Okay, what's my y-intercept? Good. -5. What's my slope? Good, 6/1. Will I have a solid line or a dotted line? Solid. It's less than or equal to, so it is solid. And then will I shade up or down? Down. Good. Okay, let's graph this one. So we have our y-intercept at -5. So we go down to -5 on the y-axis. Then our slope up 6, good. So 1, 2, 3, 4, 5, 6. over 1. Perfect. Okay. And we decided it is a solid line, so we're going to connect the dots and create a solid line. And we're shading down. Now, whenever the line starts to get really tilted like this, it can be tricky to decide which way is up and which way is down. So what I like to do is from my points or from anywhere on the line, if I'm shading down, I like to just think of it as I'm going straight down from the line. Sometimes it helps to kind of give myself a guide before I really shade it, and I see, okay, straight down from the line is actually to the right side of that line. So we're going to be shading here to be showing that it's less. Because that's technically under the line. Okay. We got that one? Ready to look at number 6? Alrighty. Last one. What's our y-intercept? 3. What's our slope?
-5/1.
Perfect. -5/1. And then will we have a solid line or a dotted?
Dotted.
Dotted. Good. And shade up or down?
Up.
Up. Good. Good, good, good.
That's what confused me was, like you was just talking about whether to decide to go up or down because they kind of look the same.
Right, right. Especially like from number 4 to number 5. Because on this one we're saying less than and we're shading to the left, but on this one we're saying less than and it looks like we're shading to the right. Might be confusing. So here's one way that I like to think of this as being different. On this one we're just looking at x values. X only, because it's saying that x is less than -2. So on the x-axis, the left is where the numbers are getting smaller. So that's going to show us where it's less. But on this problem, number 5, we're not just talking about an x value. We have an x and a y. So we need to think about the line as a whole. And since it's not just going straight up and down, it's got a little tilt to it. We want to make sure that we're only coloring in under every point on this line. The only time that we're going to be going left to right is if they only give you an x and a number. Every other time we're looking up and down. So, and I think it'll make more and more sense as we do more and more examples like that. I'll try to get lots of problems like number 3 and 4 today for you guys. Okay, let's finish up number 6. So where's our first point?
3 on
Good, 3 on the y-axis. And where should I go from here?
down -5.
Good, down -5. 1, 2, 3, 4, 5 over 1. And we have a dotted line. So let's connect our dots. Okay. Now, here's another one that's a little tricky to shade because we've got a very steep slope. So I'm going to tell you to do the same thing we did on number 5. We're shading up here, right? So I would go from any point on your line and think about where is above that line. So if I'm starting here, up. I'm starting here, up. I'm starting here, up. So I'm actually shading to the right again. If my line was tilted this way, then we'd be shading to the left. It really depends on the position of your line and where is considered above the line versus below. So when in doubt, find a point on the line and just draw a line straight up from it. If it's supposed to be greater than, shading up. So I know I need to shade where I drew my little lines. Yeah, it does look just like that one. But do we see how this one, we can tell that we're shading above the line versus in this one we're shading below. What's happening is these are just really steep slopes. Okay, if I had this tilted more this way, that would still be below. This would be above. It really depends on how it's going to look based off of the slope, really. The slope can change the way it looks. But I would always do that straight line test. Start from the line you graphed. If you're supposed to shade up, draw a line going straight up from the line. And that's where you're going to be shading. Or if you're supposed to shade down, draw straight down from your line. I think that'll help. Okay, so there is our Do Now worksheet. And that was the answer key I made earlier. And it looks like they match. So that's good. Yeah, that's really good. Awesome. Awesome. We got them all right. That's good. Okay, guys. Let's put these to the side. And let's do a little practice today with our y equals lines and our x equals lines. So, I would love, and actually before we do this, I think I am going to make some copies of, I made this page on Friday, and I think these graphs are going to be a little easier to work with because it's not pure graph paper. I left you guys some room to like write little notes to the side. Would you guys be interested in having some copies of these for your notes?
Yes.
Okay, I'm going to go make a ton of copies of this. And I'm just going to I'm going to put a ton of them over with our graph paper. So let me pause this. You guys feel free to take a little break for a minute, like 5 minutes or so, and I'll be right back. Okay, so I'm going to go ahead and title this. You guys should have copies if you want them. I would recommend grabbing a few. They're up at the front. And we're just going to do a bunch of practice with graphing. Oh. Let's do graphing inequalities. Where we're just given an x value. So x is greater than or equal to or less than or equal to or any of those a number. So I'm just going to write out a few problems, and you guys are welcome to copy these, and we're going to run through a few together, and then I'm going to let you try some on your own. So let's start with x is greater than 3, x is less than -4. 3, we'll do x is less than or equal to 5. 4, we'll do x is greater than or equal to -1. So there's 4 problems to get us started. And we'll make a note that since we're working with x, our graph is always going to be a line going straight up and down. and we're always either going to be shading to the left or to the right. And I'm going to start by giving us some coordinates, just some empty parentheses. And we'll choose solid or dotted. And shade left or right. And I'll pause it. I see we're all kind of writing, so let me give y'all a minute to get caught up to where we are. And look at number 1. So the inequality I gave you for number 1. Can somebody read this out loud to me? What does this inequality say? Perfect. X is greater than 3. So one thing I would suggest, first step here, before we even look at coordinates, is I only have an X, and then I'm given that it's 3. So the first thing I would do is I would go down to that X-axis, and I would mark my 3. Right there. Because I know I'm just looking at X, and I'm looking at 3. So I've done that. So what could I do from here to decide what my line is going to look like?
See what numbers you want for your Y.
Yeah, sure. We can pick some different values for Y. What is X always going to be in my coordinates? 3. So if my X comes first, I'm going to go ahead and fill in 3 for both of my X's. And what about my Y value? It can be any number. So give me some numbers. 5 and 4. Perfect. So I know that X is 3, so I'm only going to be moving up and down from this 3. I could go up to Y equals 5, so I'll go ahead up to 5. Mark that. And then I see I have 4 for Y. So I'm just going to go from 3 on the X up to 4 on the Y. And look at that. We know we have a line that's going to go straight up and down, going through 3 on the X axis. Now, is this going to be a solid line or a dotted line? Dotted. Good. It's just greater than. It's not greater than or equal to, so we are looking at a dotted line. So I'm going to go ahead and do my line. I'm going to dot the line. Then we'll look at our shading. Okay, so there's my line. Now for shading, this is the reason that our inequalities with just an X are a little different, because normally I can start from any point on my line and I can either draw a line going straight up or straight down. But if I do that here, it's not going to give me anywhere except for on my line. I'm not going to have a spot to shade. So whenever we're working with just X, that's why we're going to think of it as either shading to the left or shading to the right. Kind of like whenever we would have number inequalities and we would just do it on a number line. We would only have one value. We'd get X is greater than something or X is less than something. It's the same thing here. So if we have X is greater than 3, are we going to shade to the right or to the left?
Right.
To the right. Greater than 3 means bigger than 3. If I look at my numbers on my x-axis, if I went to the left, my numbers get smaller. If I go to the right, they get bigger, and that's exactly what I want. So, since it's greater, we shade to the right. Good. Good, good, good. And I bet you by the time we do a bunch of these, we won't even have to write coordinates for them. You start to get used to seeing, okay, it's just a line straight up and down going through that number. Okay, can we look at number 2? Let's look at number 2. Somebody read me the inequality I have written for number 2. Perfect. X is less than negative 4. So where can I already put a point on my graph? Negative 4 on the x-axis. Since we're looking at x. And remember, if it tells me that x is less than negative 4, it doesn't give me a y. I know that no matter what I pick for y, my x is always going to be negative 4. So if we think about it logically, I know, like, let's say I picked y as 1. My x is still negative 4. If I picked y as 2, my x is still negative 4. No matter what I do, if it's negative 4, my x is still negative 4. We're always going to end up with a line going straight up and down. You don't necessarily have to make coordinates for it, no. I think sometimes it helps to make coordinates. If you're not sure where to go, you can remember at least, okay, I know x is negative 4, so what if I just pick some random points for y? But I think the more practice we do with this, the more we'll recognize, okay, if x is less than negative 4, that's where my x is. No matter how far up or down I go, my x is in the same spot. It's always at negative 4. But if I did want to write coordinates, I'll go ahead and just label some of the ones that I wrote. I know my x is always negative 4, so I'm going to start with that. And for example, on this point right here, I chose 2 for my y. And this point down here, I chose negative 4 for my y. Coordinates are optional. It's a great way to get to having your line drawn, but I do think we'll get to a point where we don't need the coordinates. So now we're going to decide if our line should be solid or dotted, and if we should shade to the left or to the right. This is going to be a dotted line. Good. Yes, yes. We have a dotted line, and since it's less than, we go to the left. Good. So we'll connect all these dots. And we shade to the left. Alright, there is our graph for number 2. Okay, are we ready to look at number 3? I'm going to scooch to number 3. Stop me if you need me to go back. So for number 3, now I have x is less than or equal to 5. Where should I put my first point? That's okay. On 5, x is 5. So am I putting 5 up on the y-axis or 5 to the right on the x? On the x-axis. Good. I know x and I know 5. So I'm going to go to 5 on the x-axis. Now, can we recognize what this line is going to look like without making coordinates?
Yeah,
What's it going to look like?
up and down.
Just straight up and down. You guys are really going to get to a point where these are your favorites to graph because you don't have to do any work. You just know that it's at 5 and it's straight up and down. Is it solid or dotted? Solid. We've got less than or equal to, so it's a solid line. And it's just straight up and down because it's x.
So you won't require us to put a number, imaginary number.
Nope. You don't have to. Okay, so I'll write down we decided this was a solid line. Now, does anybody still want to see some coordinates for this? Would that be helpful, or is it okay that we just drew a line? Does anybody want us to still write some coordinates? Would that be helpful, or are we okay with it just being a straight up and down line? Okay, cool. Cool. All right. So we knew it was a solid line. Now let's think about which direction we're going to shade. To the left. Good. It's less than or equal to, so we shade to the left. Because all the numbers that are smaller than 5 are on the left side of my graph. Good enough. Yes, basically, that's a great way to think of it. Whatever direction this arrow, the symbol is pointing, I could think of it like this. If this is my symbol, if I drew a little tail on it, it's telling me to shade to the left. That's a good little trick to remember. And that will always work for your x's. We could look up at the others too. I had a greater than sign. Which direction do I shade? Well, if I give my greater than a tail, I'm shading to the right. My less than sign, what direction do I shade? Well, if I give it a tail, it tells me to shade to the left. Yeah, that's a really good trick. And that will work every time. Okay, so there's number 3. Okay, let's do one more together, and then I'm going to give you 2 to try on your own. So now I have x is greater than or equal to -1. So what should I do first? Let's find my x, which is what? -1. Good. So am I going to find that going up and down or left to right? Left to right. Good. My x-axis goes left to right. So here's my -1. And what does an x equals line look like?
Up and down.
Straight up and down. Good. We're just going to make a line going up and down. And is it solid or dotted? Solid. So I'm just going to do this. There we go. There's my line. And which way should I shade?
Right.
To the right. Good. Perfect. That is wonderful. So we have a solid line. And we shaded to the right. Good deal. Okay, 2 on your own, and then we're going to take our break. So 5 and 6. give you x is less than -3 and x is greater than or equal to 4. Okay. So I'm going to go ahead and pause this here. I want you guys to try to do these on your own. When you finish these two, you are free to go ahead and take a break. And let's say we will meet back together at 10:45. Yeah, that'd be crazy. Okay, I'm going to pause it now. Okay, so we are back from our break, and this is the answers to the problems I had you do on your own. Number 5, we had less than -3 for x, so we have a dotted line, and we shade to the left from -3. And for number 6, we have greater than or equal to, which gives us a solid line. It said x is greater than or equal to 4, so straight up and down on 4, shade to the right. Okay, so I would hold on to this paper, label it with something to help you remember. You know, if you forget how to graph something that has just an x, no y, you can look back at this page and remember you're always doing a line straight up and down, and you're shading to the left or the right. So I'm going to move that to the side. And just for good measure, do you guys want to run through some where it's just y equals something? Okay, let's do those as well. So I'm going to pull out one more sheet of paper like this. If you need another, there are more at the front of the room. And this time, I'm going to label it pretty much the same thing, but I'm going to write y instead of x. So, graphing inequalities. This time it's y is greater than or less than a number. Okay. Alright, we're just getting started back up. We just looked at the end of our X worksheet, and now we're starting another one, but with y instead. So I'll pause for a moment. If anybody needs to get another sheet of paper like this, I've got a bunch of them at the front of the room. It will definitely save you time grabbing one of these instead of drawing them all yourself. It's great practice to draw them yourself, but we'll save you a little time here. So on an x equals line, we're going to always have a line going straight up and down. What's our line going to look like for a y equals? Straight left to right, straight across. It's going to be the exact opposite. So whatever our number is, we mark a point at that spot, and then we just draw a line straight left to right. So on this one, we're back to our regular shading. We're either going to shade up or down. And I'll write that here as well. Okay. And I'm just going to write out a few random ones. So this one here, we'll do y is greater than or equal to 2. Y is less than -3. Y is less than or equal to -2. And y is greater than Okay. So let's look at number 1 together. I've got y is greater than or equal to 2. So I'm only given a value for y. So where should I put my first point? On 2. On the x-axis or the y-axis? Y-axis. Good. So I'm going to go to 2 on the y-axis. And we know if y is 2, then no matter where I go, to the left or the right, my y is always going to be 2. So whether I went to x is 4 or x is negative 4, my y is still at the same height of 2. Negative 4, 2. Doesn't matter what we put for x. Okay, so now we still need to decide the same things. Are we going to have a solid line or a dotted line?
Solid.
Good. We're going to have a solid line. And then are we going to be shading up or down? Up. We have y is greater than or equal to. So we shade up for the numbers that are bigger. So I'm going to draw my line and then I'm going to shade up. Here we go. And that is what number 1 is going to look like. Now, how about number 2?
On the y-axis.
On the y-axis, what did you say? You said 3 or negative 3?
Negative 3.
Perfect. On the y-axis, so I'm going to go down to negative 3. And
Dotted line.
I'm going to have a dotted line. Good. So dotted. And where could I go to help me figure out what this line is going to look like?
Your line.
My line, so if I know y is less than negative 3, that's okay.
Pick any number.
Straight across.
Pick any number, yeah, or straight across, yes.
I'm sorry.
Yes, no, you're both right. We can pick any number for x. No matter where I go on the x-axis, my height, my y, stays the same. So if I went to x is 2, my y is still negative 3. If I went to x is 5, my y is still negative 3. If I went to x is negative 3, my y is still negative 3. X is negative 6, my y is still negative 3. No matter where you go, my y stays the same. We said it was a dotted line, so I am going to trace and dot my line. And are we shading up or down? We're shading down. Because it's less than. Good. Perfect. There is our graph for number 2. You guys want to do 3 and 4 together, or do you guys want to try some on your own now? I bet y'all can do them on your own at this point. See if you can do number 3 and 4. I will pause our video, set a little timer, and then we'll go over these together. And if we got these, I think we might be ready to try something different. So I'll pause this, put a little timer up. I'll give you guys about 5 minutes, and then we'll look at them together. So number 3, should our line be solid or dotted? Solid, good. Are we going to shade up or down? Shade down, good. And where is our line going through? -2 on the y-axis, so I can just make a point at -2. And I know it goes straight across. I can make some guiding points if I want. I know it's going to be at -2 no matter where my x is. And it's going to be a solid line. So let's trace our line. And we decided we'd be shading down, so we'll shade below the line. There we go. All right. Good deal. Everybody got that one? Cool. Let's look at number 4. We can have a solid line or a dotted line? Dotted. Very nice. And will we be shading up or down? Shading up. Good. We have y is greater than -4, so we shade up. And where does our line cross through? -4. So I know it's going to go through -4. Y is always -4. I can make some guiding points. And I'm just going to trace through with a dotted line. There we go. And we're shading up on this one, we decided, so this one I got a lot to color in. Just gonna go up from there. Alright, there we go. That's our answer, number 3 and 4. So now we have 2 little guides. We know how to graph a line that just has an X. We know how to graph a line that just has a Y. So, awesome, awesome, awesome. I'm going to take these papers and put them to the side. And I'm actually going to have you take notes on one of these again because we're still graphing. But I'm going to show you something different now. Just slightly. Just a little different, but I think you already know how to do it. So, we're actually going to backtrack a little and go backwards towards equations. We've been working with inequalities. Now we're just going to go back to equations. So we don't have to worry about shading. We don't have to worry about dotted or solid. We're just going to do regular old lines. And I'm going to label this as my day 16 notes. And again, I made a ton of copies of this paper, so feel free to take all you need. I can make more. Day 16 notes. It's Monday, February 10th. And we've been working with graphing equations, graphing inequalities. Now we're going back to equations and we're going to talk about systems of equations. That's a little wonky, but it's okay. So systems of equations are not that bad. All we're doing is, instead of graphing one equation, we're graphing two equations on the same graph. The only extra step we have is there's going to be a solution that we find using our system. So, for example, let's say I give you, let me grab one that I know will give us a nice, neat answer. I've got some copies made over here. Let's try graphing. Make this a little more zoomed in. We're going to do y equals 2/3 x plus 1 and y equals negative x plus 6. Okay. So here are two equations. Y equals 2/3 x plus 1 and y equals negative x plus 6. So going back to what we talked about, whenever we are graphing an equation, we're going to just break it down step by step again and look at one equation at a time. So if you look back at our do now, I wrote out a couple of steps. Our do now was this, where we were graphing our linear inequalities, and I had listed a y-intercept, a slope, and then the solid dotted shading. We don't need the solid or dotted, and we don't need the shading, but we do need the first two things, the y-intercept and the slope. So if that helps, maybe you can list it off to the side or just under it. I'm going to write it just kind of under it. So let's start with our first equation here. We have y equals 2/3 x plus 1. What is our y-intercept? 1. It's always that number at the end. My y-intercept is 1. And what's my slope? Not negative.
I'm sorry.
That's okay.
I'm sorry.
That's okay. Yes, my slope is 2/3. So let's graph this line first. So if my y-intercept is 1, where should I put my first point? At 1 on the x or the y-axis? On the y-axis. Good. So I'm going to go up 1. And where should I go from there?
Up 2
Perfect. I'm going to use my slope. Up 2/3. So 1, 2, and 1, 2, 3. Okay, so there's my 2 points for my first line. What's the last thing I need to do to graph the line? Just draw a line through it, connect the dots. So there is my first line. Now let's look at our second line. What would our y-intercept be for y equals negative x plus 6? 6. Good. My y-intercept is 6. And what's my slope? Perfect. I have a negative x, which means our slope is negative 1 over 1. So where does my first point go? Positive 6 on the y-axis. And using my slope, how do I find the next point? Perfect. I can go down 1 over 1. And to make sure our lines cross in the correct place, because this is where it will be important that our lines are accurate, because we're now going to find where do these lines intersect? Where are they touching and going through each other? So something I like to do to make sure I'm getting an accurate line is I'm going to continue with that slope. I started at my y-intercept. I went down 1 over 1. Maybe I want to go down 1 over 1 again. Down 1 over 1 again. Oh, it's going to go through right here. Down 1 over 1. This is an optional step, but it will make your line a little bit more precise because you'll have more points to go through. Sometimes when your points are really close together, it's easy to tilt your ruler a little too far. So I like to give myself a few points. And we're just going to connect those dots. And there it is. We just graphed a system of equations. It's not so bad, is it? Not too bad. It's just an extra step. Now, the very last thing we do have to do on a system of equations, and on a quiz, I will give you a space to do this. I'll make sure to write instructions so it's not something that you'll forget. But we are supposed to be trying to solve a system of equations, and the solution is the intersection. So we're going to write the coordinate where the lines cross each other. So what would this coordinate be right here?
3.
So we go over 3 in the x direction. So we have positive 3 for x, and our y, I heard somebody say negative 3, I heard someone say positive 3. Which one is it?
Oh,
Positive 3. Good. That would be our solution. Not so bad, not so bad. Now I'm going to give you guys a little key. This is completely optional. You don't have to write this down, but I was just thinking of it as we were labeling this coordinate. There is a trick to remembering when your x is positive, when your y is positive, or when it's negative. So to the side, I'm going to write a little thing for you guys. If this doesn't help you, you can ignore it. But what we have here in our graph, we have 4 little sections, and these are called quadrants. Okay, and I'm not going to test you on this. But in each quadrant, you're always either going to have a positive x and a positive y, or one of each, positive, negative, however that goes. But there is kind of a formula that you can follow, and I'm going to kind of give that to you here. So up here in what is our first quadrant, we use Roman numerals to label. This is first quadrant with a little I. Our x value is always positive, and our y value is always positive. Again, this is optional to write. If you think this will confuse you more, don't worry about writing it. So I'll label x and y. And then we go in a counterclockwise motion. So a clockwise motion is going in the direction that a clock goes. kind of turning this way, we're going to go backwards, the counterclockwise. This is the second quadrant over here. And over in this section, do you think our x is going to be positive or negative? Negative. Good. Our x is negative over here because this is to the left of 0 on the x-axis. And our y value is still positive because it's still above 0 on the y-axis. I wonder if it would help to put some green for positives. And we're going to continue that counterclockwise motion. This is 1, this is 2, this is quadrant 3. 1, 2, 3. Oh, you're okay. Bless you. In the third quadrant, we're going to the left on the x-axis. We're going down on the y-axis. You think our x values are positive or negative? Negative. Good. What about our y's? Also negative. Good. Bless you. Let's see. I feel like I need like a colored pencil. Use crayons. There's my positives. My negatives. Okay, and then last but not least, this is quadrant 4, which we do with an I and a V. Because in Roman numerals, V means 5, and then we put 1 behind it, and it subtracts 1, so this is 4. Roman numerals are interesting. I'm not testing you on that, but good to know. And do you think our x values are going to be positive or negative? Positive, because we're going to the right of the x-axis. So our x value is positive. And how about our y values? Negative, because we're below 0 on the y-axis. Good. So, if this guide helps you, great. If it doesn't, ignore it. Just thought I'd throw it out there. What'd you say?
It just picked into my head the last one what you're doing, then I seen it now it's stuck.
Well, good. Good. I know, sometimes it takes a minute. I'm like, what is... Oh. Takes a minute for the gears to turn. Yeah, but there's a little guide that'll help us. I know if I have a coordinate over in this area, my x and y are both positive. If I'm over in the second quadrant, my x is negative and my y is positive. If I'm in the third quadrant, they're both negative. If I'm in the fourth quadrant, my x is positive, my y is negative. So there you go. Okay. So I am going to zoom out a little so that y'all can still see that if you're still writing it. And I'm going to give you another system of equations that we're going to graph. Let's do y equals negative 3 over 4x plus 2. And I'll give myself a space to write the y-intercept and the slope. And then let's do y equals positive 3 over 4x minus 4. Okay. I'll zoom in on this so y'all can see it better. So here's our second system. So let's look at the first equation. We've got y equals negative 3 over 4x plus 2. What's my y-intercept?
2.
2. Good. It says it right there. 2. What's my slope?
Negative 3 over 4.
Yes, negative 3 over 4. Okay, so let's graph this line first. Where's my starting point?
2.
2 on the y. Yes, thank you.
Up 3, down 3.
Perfect. Down 3. Good catch. 1, 2, 3. Over 4. Good. 1, 2, 3, and 4. So here is my first line. I'm going to connect those dots. And again, it's good to be as precise as possible. And if it helps to give yourself another point, remember you can do the same thing. I'm going down 3 over 4, down 3 over 4. I could also go 1, 2, 3, 4, 1, 2, 3. Let's see, 1, 2, 3. Negative 4, I believe that's a point. Okay, I'm going to connect those. Okay. So there's my first line, and let's look at our second one. Got y equals 3 over 4x minus 4. What's my y-intercept? Good. Negative 4.
Up 3.
Perfect. We're using our slope 3 over 4, so you'll go up 3 over 4. So I'm going to start at negative 4 on the y-axis. And I'm going to go up 1, 2, 3, over 1, 2, 3, 4. Oh my gosh, it's crossing right through a point we already made again. It's always nice when it does that. Then you don't have to guess. So we just connect the dots. And let's see. There's our system of equations graphed. Now we just need to label our solution. And remember, the solution is the intersection. It's where the lines are crossing. So we need a coordinate. And I'm going to zoom out a little and look back at our guide that we made. Which quadrant is this intersection falling in? Positive and negative. This is the fourth quadrant. So I know my x value is going to be positive. I know my y value is going to be negative. I'm going over to the right and down 1. So what is my coordinate?
4.
Yes, 4, positive 4, and negative 1. Awesome. And honestly, now that we're doing this using the little guide we made, I actually think that is going to be pretty helpful moving forward. Because it's a good way to kind of double check it and make sure that you're going the right way. So, I'll be referencing that from now on, I think. Okay, you guys want to do one more together? Or you want to try one on your own?
Can we show one and go over it?
Yeah, okay, let's try some. Okay, so let's see. I am going to give you let's do y equals negative x plus 3 and y equals x plus 1. And remember, if we don't have a number next to x, it's that invisible number 1 there. So just remember that when you're figuring out your slope. Okay, so I'm going to leave that up, and I'll give you guys a little bit to do that. Make sure you also label your coordinate. I'll pause this. And if anybody needs help, just holler at me. I'll come around and see how we're all doing. So this third problem I gave you a little bit of a curveball because I didn't give you a number next to x, but it looks like most of you guys navigated that really, really well. So I would love for somebody, some brave soul, please guide me through graphing just this first line.
Y-intercept is 3.
Perfect. Our y-intercept is 3. So where should my first point be?
Should be on 3 on the y.
Yes, 3 on the y-axis. Now what?
My slope is negative 1 over 1.
Yes, my slope, because I have negative x, is negative 1 over 1. So where should I go from 3?
So 1 down,
Perfect. Down 1
and then 1 over.
over 1. There's my second point. Amazing. I'll go ahead and connect those points. Awesome. And who wants to do the second line?
You want to go ahead.
Oh, I thought Keith was going to do it. The y-intercept is a 1,
Perfect. Y-intercept is 1.
and the slope to x is just a point. It's a 1.
Perfect.
Over 1.
No number next to x, so it's 1. Our slope is 1 over 1. So we go up 1 over 1, and it's right here. They share a point. So we will connect the dots again. Amazing. All right, so we have our lines graphed. What's the last thing I need to do in a system?
Write our coordinates.
Yes, we need to write and label our coordinate. The intersection is the solution. So we see that this coordinate is in the first quadrant. So you should have a positive x and a positive y. What are my values for x and y?
Positive 2.
Positive 2, is that my y or my x?
X.
Oh, yes, this is actually, our 2 is how high up it is. That's going to be our y value. So the y goes here. So we have x and y. I always like to think of the y as, the y tells us how high. The y gives us our height. So we are up to 2 on the y-axis. And then how far over are we on the x? 1. So our intersection would be 1, 2. 1, 2. Okay, does anybody have questions about how we got this? Did anybody get something different? That's really good. Good, good, good. Okay, guys, it is almost 11:40. We've got about 15 minutes. I think I would like to go ahead and give you an exit ticket. And it's just going to be one problem today. If you want to do your exit ticket on one of these pieces of graph paper, that is fine with me. I'm going to have you graph a system of equations. If you would like to wait, I can also make copies, but it's pretty much going to be just like this. So this way, if you mess up, you have lots of graphs to start over on. Okay, so this is day 16. Day 16 exit ticket, and this is due on Friday, February 14th. That is Valentine's Day. I know. So I'm going to write that due Friday, February 14th. And again, if you're worried about copying the problem down correctly, if you want to wait, I will make copies of this. So your directions for this exit ticket are to solve the system of equations by graphing. And when I say solve it, that just means find the coordinate where they cross. So you're just going to graph both lines, and then you're going to tell me what is the coordinate of the intersection. So I'll write that down. Solve the system of equations by graphing. Label the coordinate of the solution. X, Y. Okay, so just one question today. It is going to be, find a good one. Let's do y equals x minus 2 and y equals 2/5 x plus 1. And over to the side, I'm going to give you a space. Solution. Okay, so I'm going to freeze this screen, make some copies. If you would like a copy, I will have one for you in just about a minute here. But that is it today. You are just going to graph one system, the one I just gave you. That's your exit ticket today. And if you finish it before 11:55 and want me to grade it, I can grade it for you before you go. So that is all. I'm going to end the video there.